Okay, this is called the rationalizing technique, which is the same idea as find a function that's the same function everywhere except at x equals 0. So what I'll do here is we call this rationalizing the numerator, which you're not used to, maybe. You've done some rationalizing the denominator in algebra class. So the goal here is to see what happens when I get rid of the irrational value in the numerator, the root. All right. So what I'm going to do is multiply both the top and bottom by the conjugate of the numerator, which is x plus 1 plus 1. All right, the conjugate of a minus b is a plus b. And the good thing about these things, when we multiply them together, we lose the middle term, right? A minus b times a plus b, when you FOIL, is a squared plus ab minus ab, they go away. And you can just square the two terms and put a minus in between. But if I do that in the top, I got to do that in the bottom. So we're multiplying by a form of 1. Okay, so what happens? Well, the numerator, this is equal to the limit as x goes to 0. Root x plus 1 squared is x plus 1. Minus 1 times 1 is 1. In the bottom, nothing's really going on here. I can't really simplify that. So I'm not even going to multiply it through. I'm going to leave it like that, see what happens. Okay, so 1 minus 1 is 0. So I have the limit. As x approaches 0, the limit, as x approaches 0 of x, right? These went away. X over x times square root of x plus 1 plus 1. And here's, remember, the goal is to plug in 0. I didn't even say that at the start. We can't plug it in because I'm dividing by 0. But if I multiply by this form of 1, I'm going to get a function that's the same everywhere except at x equals 0. Sort of like our dividing out technique. So the x's cancel out. So we have 1, and then I'm left with this thing. Right, and now I can plug in my 0, right? Because I have 1 up top, now direct sub, 0 plus 1 plus 1, and I end up with a half. Okay, so that's my next method here. And we can see that's true. You can always check your work by back to the numerical approach. Approach 0. Where are we going? We're going to 1/2. Okay. So that's the rationalizing technique. So I had a list going before. There you go. Not very neat list, but it's a list. Rationalize. Okay. What's wrong with my pen here? All right, so that's kind of a summary, a messy summary of limits. We can do numerical, graphical, but mostly I want you to do some analytical stuff. Direct sub, we won't do the squeeze too much. We'll do dividing out, we'll do rationalizing. And there's one more, I'm going to kind of leave it to you to try and discover on the homework. The algebra should look familiar. What you're going to see is you're going to ask to evaluate the limit of just like a messy, it's kind of straightforward in terms of the algebra. If I gave you a function like this, if I gave you a function like come on, pen, what would you do with it? Well, you know how to deal with the algebra, all right? That is, this is a complex fraction, right? This big fraction, you got fractions within fractions. So the idea here, you can't plug in 0, right? But the idea here would be to get a function so that you can plug in 0, okay? So that means you're going to do what you would do from algebra. This was on your review. One of these was on that algebra review, and get rid of your complex fraction. Okay, and once you get rid of your complex fraction by multiplying top and bottom by LCD, right, run that guy through, then you should be able to evaluate it. Okay, so I'll leave that last method. What name do we have for that last method on my list here? Well, oh, some more room. I don't know if we have a method. I guess we could just say simplify complex fraction, and then do your direct sub. Okay, so that should get you through the analytical part of evaluating limits.